Hello guys and welcome to today's video on linear models, part of the further Maths Unit 3 and 4 course, but actually relevant to the whole world. So if you're watching outside of Australia, welcome, thank you very much. Linear models, what on earth is this all about? Well, basically, yes, we are looking at taking a lot of real world situations and making them fit equations. Now, if you haven't already done so, do me a favor, head over to YouTube and subscribe. Never going to be rich and certainly never going to be famous, but knowing that you are watching actually means the world to me and it just keeps me going. Also, MaffsGuru.com is my website, which has all the videos sorted by textbooks, downloadable notes, and all searchable. And there are exams, questions, and all sorts there for you as well. Hopefully the best thing you'll do today. Now, yes, we've done a lot of work previously on finding equations of straight lines that will very much apply to what we're doing now. So the learning objective is pretty much to apply all that stuff we've done so far to be able to extract out that stuff from worded problems. Now, lots of people hate worded problems. Do you hate worded problems? Oh, I did when I was a kid. I was like, what do I, too many words? I'll just colour in instead. That's closer to the truth than you want to believe. But taking out the important information, knowing which subject to deal with, makes life a lot easier. Lots of what we do in life actually has linear equations stuck to it. Now, I'm going to oversimplify lots of things, but for example, I used to work in a hotel and people used to get cabs from us all of the time. Now, I don't know about you, but when you used to sit in a cab, I never fully understood why, before we even moved, the guy went beep, 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 and added on $4 before I even started. It's like, well, hold on a moment, where's what, huh? Now, that's actually just a fixed cost, and we'll come back to that in just a moment, but there are certain costs associated with a taxi that means that, well, as soon as you start going, then for every kilometre you travel, sort of, they'll charge you the same cost. So that's a linear relationship. The further you travel, the more they'll charge you. If you hire, I don't know, something from Bunnings, they'll charge you a fixed cost and maybe however long it takes to have it for so many hours. Hiring a car, there's a fixed cost, and likewise for how many kilometres you do. Lots of things have some sort of maths related to it that's quite funky and must be how computer systems charge you. Now, obviously, we need to be very careful about the language here, all right? And as I say here, there are things which are fixed costs, all right? Things that basically, before you even do anything with what you're hiring or what you're using or what you're buying, you've already paid that figure, all right? So basically, I could get into my cab, not move anywhere and get back out my cab and I owe that guy $4, right? Why? Because, well, I've no idea really. I've sat in his cab, I suppose. But that fixed cost I've got to pay regardless of whether I move any kilometers. Obviously, the further I then go, the more I'm going to have to pay. If I hire something for a day, I don't know, a carpet cleaner, for example, and I sort of hire it for $50 and take it outside and then bring it straight back in and changing my mind, I still own that $50. I may not have used it, but I've obviously had some sort of fixed cost. Variable costs are costs that will change with use, pretty much. So like I say, the further I go in my cab, the more I'm going to pay in terms of distance traveled. I'm going to use two examples to sort of highlight. And the thing is, although I'm going to show these two examples, there are lots of different ways of framing the maths. So please don't think that just by using these two examples, you're going to be guns at this stuff. It's for you to pull out the important information. And generally speaking, if you remember for straight lines, we need an intercept and a gradient, or a point and a gradient. So some sort of point on the line and a gradient, or some sort of intercept and the gradient. Ofcom's rates for local calls from private telephones consist of a quarterly rental fee of $40. Now, before I go any further, my brain, because I know what I'm looking for, tells me that that there is my fixed cost. Doesn't matter if I don't make any phone calls whatsoever, that is my fixed cost. And then 25 cents for every single call. So reading this, I've got to try and work out, what have they given me here? Have they given me a gradient and a point? Have they given me 2 points? Well, actually, as it turns out, they've given me a gradient and they've given me an intercept. It says construct a linear rule that describes the quarterly telephone bill and sketch the graph. So the first thing is we've got to get the equation and then we're going to sketch the graph. All right, so as I say here, the fixed cost is called the rental fee. Basically, long story short, as I say, if I now have here, what have we got here? I've got my number of calls, and up here I'm going to have my cost. Now notice we don't even have X's and Y's anymore, right? We've got call, all right, or the number of calls, so maybe we'll actually change that to N to stand for number of calls. and the cost of those calls. It doesn't matter if I don't make any calls, I already am going to pay $40. So there is my y-axis intercept. What about the gradient? Well, as I say, there is my y-axis intercept. This is my gradient. It's 25 cents for every single call. Now again, how has the question tried to trick me here? What do you notice? I've got $40 and I've got 25 cents. So this question is evil because they're giving me different units. So I have to change my 25 cents into 0.25 dollars. I don't know why I put the dollar sign afterwards. I've been marking too many of my own students' works. All right, so now that they're in the same units, I've got my intercept here, and actually this is my gradient. Do I have everything I need? Absolutely. Oh, there's another trick. Oh no, what's going on here? Well, we've said that my intercept was equal to 40, and we knew my gradient now is equal to 0.25. And while we can absolutely have gradients as 0.25, we can have that, it's not a major issue. I probably would want to know what that was as a fraction as well. Now, a lot of these you have to learn. There are a number of fractions you should learn. So very simple, 0.5 is a half, 0.25 is a quarter, 0.125 is 1/8, 0.1 is a tenth, and there's lots of others. So if you can, maybe Google and see what the most important fractions are out there and try and learn them, or at least put them in your summary book. All right, so why do we need to be able to know fractions? Because we know that if we have a gradient written as a fraction, we can do rise over run. And bearing in mind this question wants us to sketch the graph, we're going to try and do everything we can to make it easier for ourselves. And so we can now complete the question. We know that m is equal to 0.25, which is a quarter, and we know that c was equal to $40. All right, so assume the minimum number of calls is 0, and the point that the maximum number of calls is going to be 200. Now, I've added that in there because they didn't give you any more information. It makes life a lot easier if I do. So, first things first, I'm going to draw myself a set of axes. Here is 0 calls. Let's do 50, 100, 150, and 200 calls. Now, at the moment, I don't actually know how much it's going to cost me for 200 calls, but that's okay because I'm going to be able to use a formula, because I now know that I've got y is equal to mx plus c. Now, what's on my y-axis in this sense? It is the cost of the call. So I'm going to actually write that as cost is equal to the gradient we knew was 1/4 times what was along my x-axis. I'm not going to write x, I'm going to write n, which is my number of calls. So let's just do num times num plus c, which was $40. All right, so what can I now do? Well, I want to try and find a point on this line using that formula. So I'm now going to say we'll let the number of calls equal 200. So I now know the cost is going to be 1/4 times 200 plus 40. Well, a quarter of 200 is 50, yep, plus 40, which gives me 90. So I now know that my maximum height of my y-axis is going to be 90 in this situation. 10, 20, 30, 40, 50. No, I'm not going to be able to do that. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Marvelous. So I now know for 200 calls, I'm going to do a cross. Let's just make sure that I put it in the right place at 90. And I also know that my y-axis intercept is there at 40. And I can actually join those two together. Now, there's lots of ways of being able to do this. And again, that line shouldn't finish there. It should continue to the bounds of my graph. But ladies and gentlemen, I have all the information I need. Now, to be able to complete the question, to sketch the graph, I had to come up with my equation. So because I had the information in a nice form, I could actually come up with my cost. And it made life a lot easier for me to work out one of the costs or one of the points on that graph. Now, I could have chosen any. I could have chosen 100 calls. I could have chosen 150 calls. It doesn't matter. All I needed to do was make sure that I substituted into my right equation to work out the cost that was $90. Now, here is a slightly more complex example. And again, I can't do all examples in the world, but this one now is basically trying to trick you by giving you two coordinates. The tires on a racing car had lost 3 mil of tread after completing 250 kilometers of a race, 4 mil of tread after completing 1,000 kilometers, assuming that the loss of tread is proportional to the distance covered. Now, basically that just means assume that it's linear, all right, in this situation. Find the total loss of tread D after S kilometers from the start of the race. So the first thing we need to do is go back to a concept from the very beginning and go, well, which one is my explanatory variable and which is my response variable? Well, the more distance I do in a car, the less tread I'm going to have. So it would appear that distance, which they said is going to be S, is going to be the amount of the tread on my car. So S and D. All right, now, looking back at the question, they've given me 2 coordinates, but you can't be tricked. We've got to write our coordinates in D. Sorry, try that one again. We've got to do our coordinates as S followed by D. So my distance followed by my tread. Now, if I was to write them in the order the question gave me, I'd make a stupid mistake. So in this situation, my coordinates are given as 250, 3 and 1,000, 4. So before we even start this question, we've got to make sure we got the axes the right way around, the numbers the right way around. But now that I've got it, I've got 2 coordinates, I can use my theory to find my equation. So let's find my gradient first. My gradient is y2 minus y1 on x2 minus x1. Okay, so y2 minus y1 is 4 minus 3 over 1,000 minus 250. Now, 4 minus 3 is 1. 1,000 minus 250 is 750. And yay, there is my gradient. So now I'm going to substitute that into my equation, and I'm going to get y minus y1. So let's use this one. I'm going to use this coordinate here. Y minus 4 is equal to the gradient 1 on 750 times x minus x1, which is 1,000. Right, now, ooh, this is gross. Let's add 4 to both sides. Get 1 on 750, x minus 1,000 and plus 4. And then doing that gives me, multiplying that out gives me 1 on 750 x. 750, so we're going to minus 1,000 on 750 plus 4. Now, when I put that into my calculator, and I'm going to trust that you can do that as well, I'm going to get 1 on 750 x plus about 2.67, I think it is. Let me just check on my calculator. Yeah, about 2.67. Now, do you notice the problem I've got here? Oh, I've used x's and y's, but actually I shouldn't have done that. So what I'm now going to do is, although I've got my working out using the equation, I'm going to make sure that I now say that actually my D is equal to 1 on 750 times by S plus 2.67. Now, has that finished the question? No, not really, because the question didn't really ask me to find that formula. I need to find the formula because it says, what would the tread loss be by the end of 2,000 kilometers? So what they are saying is create the formula and then use the value of S of 2,000 to find the value of D. Whew, a lot of questions here. So having done that, and obviously I've got my calculator here, what can we see? Well, we've decided that we know that we've got my formula said that the amount of tread is given by, so the amount of tread is given by 1 on 750 times the distance traveled plus 2.67. The question said we've traveled 2,000 kilometers, so I know now that that becomes 1 on 750 times 2,000 plus 2.67, which when I put it into my calculator, as you can see here, gives me, and it wants it to correct to 1 decimal place, 5.3 millimeters of tread. Now, as I say, this is the end of this video, and there is no way I can do every type of question. But for the linear model stuff, look for fixed costs, look for variable costs. In the question, look for stuff that could be an intercept and a gradient, or for stuff that could have 2 coordinate points in it. If it's got 2 coordinates, make sure you don't get tricked. Work out from the question which is my explanatory and which is my response variable, and hopefully you are a significant way forward to go forward. But you know, we make mistakes in maths. Don't worry about it. Life is filled with mistakes. It's what you learn from those mistakes. If you haven't already done so, can you subscribe or head over to MaffsGuru and sign up? But otherwise, I think I'm done. Thank you very much for your time. It's really good to see you. Hopefully this has been helpful. If it is, and you're on YouTube, leave a comment below. And if you're MaffsGuru, just do me a favor and sort of take out a subscription. I'm done. I look forward to seeing you in another video. Take care, guys. Bye-bye, and stay safe.